All right, y'all ready? All right, so today we're gonna finish up the product rule, quotient rule. We're gonna start the chain rule, hopefully finish the chain rule. And so pretty much today is all about continuing to take derivatives using some sort of shortcuts. And then on Thursday, we're gonna spend the entire day doing word problems that are related to business. So we're gonna get all the mathy stuff out of the way first, and then use all that math on Thursday to do application problems. And then we will have our test a week from today. All right, our first test. It'll cover pretty much everything that we've covered up to this point, including this week. So, yeah. And I'll try on Thursday to give you some sort of idea of what to expect. But I can tell you right now, your best study guide for the test is your homework. All right, so I'll be going through the homework problems, and I'll be picking problems that are similar to those. So like, let's say I assigned a problem number 21, I might put number 22 on the test. So everything's gonna be in line with what you see in homework, all right? Okay, so let's get the product rule and quotient rule finished up. We started this at the end of last class, and I gave you two formulas, which we're gonna use throughout the class today. The first was the product rule. And it said that if you had two functions that were being multiplied together, that if you want to take the derivative, then it's the derivative of the first function times the second one plus the derivative of the second one times the first one. So that was your first formula. And then the quotient rule I had just put on the board, and we had to end class. So we never got a chance to use the quotient rule, but it says if you have division instead of multiplication between two functions, that it's going to look a lot like the product rule, f prime g, but this time it'll be minus g prime f, and then all of that over g squared. So these formulas are very similar. This one has a plus, this one has a minus, and then of course with the quotient rule you also have to divide by g squared. So let's just do some examples, all right? And you'll see these rules in action. Okay, so we're going to start off with this one right here. There we go. All right, so you have a function, and I should maybe put over here the power rule. Let me put this over here. Power rule. This was the first one that we learned. It said that if you take x to a power and take the derivative, that the power comes out and then you subtract 1 from the power, right? That was the power rule. So we cannot use the power rule here. Not the way the problem appears. And the reason we cannot use it is why? Yeah, there's multiplication here. There's multiplication right there. And because of that multiplication, you have a product, right? Now, could you get rid of this multiplication by distributing the 5x squared through the parentheses? You could. In fact, I'm going to do that after we do it with the product rule, and I'm going to show you we get the same answer both ways. All right? But you'll see later that the multiplication through sometimes is not as easy as this one is. All right? So I'm going to try and do this with the product rule first. So I recognize that I have a product. I just like to put a dotted line between them. That's just so I can see that I've got two things being multiplied. I like to designate this one as f and this one as g. So it kind of follows the format of the formula. I've got an f times a g. And so what I need to do is take the derivative of f, multiply it times g, plus the derivative of g, and then multiply it times f. So we're going to, I talked about this last class. It's kind of like they take turns getting the derivative. First f gets the derivative, g doesn't. Then you add to that, g gets the derivative, and then f doesn't. All right? So let's see if y'all can help me out on this. The derivative of this function should be, now the formula says f prime first, right? So the derivative of f. So let's just cover that up. There's f. What's the derivative of f? 10x, right? That's power rule. The 2 comes down, multiplies, hits the 5, becomes 10. The power comes down by 1, so it becomes x to the first power. So we've got 10x. We good? Then I say times, and now that's my f prime right there. Now I'm supposed to multiply that times g. So I'm going to take g. I'm not taking the derivative of g, right? That's g. So I'm just going to slap g right here. In parentheses, x cubed plus 1. Is that all right? What should I write next? Derivative of g. Before that, though, plus, right? I need the plus, so I'm going to put plus, because that's the formula. Now I'm going to do the derivative of g. That's next. So there's g, right? There's g. It has 2 terms separated by addition. So when you have 2 terms separated by addition, you can take the derivative of each one separately. So what is the derivative of x cubed? 3x squared, right? Then plus derivative of 1 is 0. So you just get 3x squared. So I'm going to put that there. And then I have to say times, right? Times f. And what is f? 5x squared. Now I did not put parentheses around the 5x squared. Why? Like I did the parentheses here, right, when I put the g here, but I didn't do it on f. Why? Yeah, this has 2 terms, right? And because there's 2 terms, this f prime, this piece, we'll have to distribute through to each one. Here, because f only has 1 term, there's no distribution that has to happen, so you don't need parentheses. Pardon? You can use them. It's not incorrect to have them. Okay, so that is my derivative. I'm just going to clean it up a little bit. And what I mean by clean it up is, yes, I'm going to distribute this 10x through this parentheses. So what happens when I multiply 10x times x cubed? 10x to the 4th. And then what happens when I multiply 10x times 1? Just get 10x. Okay, now over here, you can multiply those together, can't you? What do you get when you multiply these together? So plus 15, so that's the 3 times the 5, and then x squared times x squared is x to the 4th. And I believe we have one more step here. We can combine some like terms. These both have x to the 4th, right? So I can put them together. 15 of these and 10 of those should give me 25 of them. Yes? That's it. That should be the answer. So that was a little bit tedious. You might agree with me on that. Let me show you, if we had not done the product rule and had distributed this through first, let's see if we get the same answer. So if we distribute that through first, what would this have become? So 5x to what power? 5th power, right? You're adding the exponents. 2 plus 3 is 5. And then you distribute here to here, and you get plus, what is it? 5x squared. See, now you don't have parentheses, right? So you don't have product rule anymore. And if you take the derivative of this, you can do them separately because they're separated by addition. So what's the derivative of this? Well, the 5 comes down, 25, x to the 4th, right? And then derivative of this, 2 comes down, 10, x to the 1st power, right there. So I agree, this would have been easier, right? But again, sometimes the functions are not, it's not easy to do this part. So this is just a first example to help you kind of see how it works and to make you believe that we get the same answer, even though it's a weird looking rule, we get the same result. Okay, let's do another example. How about this one? C of x, So this might be like a cost function or something like that. C of x equals 0.5x minus 4. And then we have 0.2x plus 1. All right. So again, you cannot just use the power rule. Can't just use this because you have a product right there. Okay, you have multiplication right there. So because you have multiplication here, you can split it up. Look at this as being F and this as being G. Now, could I have distributed this all out, like FOILed it all out first? Yes, and if I did that, I could avoid the product rule. I could, but again, as we proceed, that's going to be harder and harder to do. The two things being multiplied, you're not going to be able to do that. I'll show you an example. We're just not ready for it yet. All right. So what should I do here? If I want the derivative of this, I'm going to do f prime g plus g prime f, right? F prime g plus g prime f. So what is the derivative of f? What's the first piece here? So what's the derivative of this? Just 0.5, right? Okay, so separately, right? We can do these separately. Derivative of a constant is 0, so that's going to go away. The question is, what's derivative of this? And you could look at the 1 comes down, and then you have x to the 0. Or you could just remember that constants come for the ride, and then what's derivative of x? 1. We talked about that. So either way, you could use power rule or that other rule. You should get for this, the derivative is 0.5. Is that clear for everyone? How I get that? Okay. Now what comes next? Times g. Just g, right? Just g, which is this. And I should use parentheses or not? Yes, absolutely. So 0.2x plus 1. All right, so all I've done so far in the formula, I've done f prime, there's that, times there's g, now I need to do plus, then I need to do g prime, and then I need to do times f, right? That's what I'm going to try and do here. So I'm going to put plus. What is g prime? What's the derivative of this? So what's derivative of that right there? This right here. Just 0.2, 0.2. And then derivative of 1? Is 0. So I'm just going to get 0.2 and then f. So I need to just write this thing out right here and put it in parentheses. So 0.5x minus 4. This all right? And now the final step is just to clean this up. So I'll distribute this through. And let's see what we get. So what is 0.5 times 0.2x? 0.1x. And then 0.5 times 1 should just give you 0.5. Or you can say 0.5, it's the same thing. And then this times this is going to give you another 0.1x. So plus, don't forget the plus, 0.1x. And then 0.2 times negative 4 is going to give you negative 0.8. That. It's better. It's better, but still not good enough. All right. Here we go. These two can come together, right? What is that? 0.2x. So you're adding these together, right? 0.1 plus 0.1 is 0.2x, and then these two together. Be careful with this. When we put this together with this, negative 0.3. There you go. That's it. Questions? Okay, y'all ready for some quotient rule? Okay, let's do some quotient rule. Now, when you're doing the test next week, I'm not going to tell you which rule to use. Like, I'm not going to tell you use quotient rule or use product rule. You're just going to have to be able to look at it, recognize what you're working with, and use the appropriate rule. Are you going to have to remember these? I'm not sure. Let me think about that. I'd start preparing to know them. Because really, what you want to do is get to a point where when you're working through those word problems, right? Like, you know how to take the derivative. You don't have to refer to something for it. Just like the power rule. Do you have that memorized, or are you just like you're just doing it, right? Like it's in there already? You kind of want to have that same thing for these. See how it goes. I mean, if you do your homework practice, you'll pick them up pretty quick.
When is our test? Tuesday or Thursday of next week?
I already announced that, sir.
Okay.
Beginning of class. It's in the schedule, though. Okay. How about this one? All right, so is this obvious that you have a quotient? I mean, when you see the fraction, you should be thinking quotient. So you know how on the previous problems I told you could kind of get around the product rule? You could have like distributed in the beginning and not had to use the product rule. On this one, there's no like get around the quotient rule. You have to apply the quotient rule, all right? So we have to apply this formula. So the way I want you to think about it is kind of the way I presented it, which is the numerator, right? The numerator up there is basically the product rule, isn't it? Except with the subtraction. That's the only difference. But then when we're done at the end, we have to divide by something that we didn't have to do on the product rule. So let's go for this. I'm going to identify the numerator as being like the f and the denominator as being the g. So the entire f is this and the entire g is this. So according to the formula, the derivative of this function should be f prime, then g, minus g prime, then f, then all over g squared. So let's start with the top left corner. What's f prime? So what is the derivative of the top function? Just 3. And then I'm going to multiply that times what? G. Now what's g? 2x plus 1. And should I put that in parentheses or not? Yes, I should, because g has 2 terms, doesn't it? So that 3 will have to distribute through. Okay, so that right there is f prime times g. Now I need to do minus. So minus, now what's the derivative of g? So there's 2 pieces. Derivative of this, 2. Derivative of that, 0. So it's just 2. And then times, do I need parentheses? I'm supposed to multiply times f now, right? This is supposed to be g prime, then times f. So f is just 3x, right? I don't need the parentheses around that 3x. I don't need them, but it's not wrong to have them. If you don't put the parentheses, just make sure you put a little dot here so you know it's 2 times 3, all right? Either way, it'll work. So that's almost the quotient rule. We have one more element to throw in here, and that's a big old division bar. And then on the bottom, g squared. Now g is the denominator, right? So I'm just going to take that denominator, 2x plus 1, and square it. And then I'm going to proceed to clean up the numerator. And when I say clean up, I mean let's distribute that 3 through, and let's go ahead and put those together. So what happens when I distribute that 3 through there? 6x plus 3, and then over here, minus 6x, right? And then all of this over 2x plus 1 squared, right? And notice something happened in the numerator. It's kind of interesting here. This and this go away, don't they? And all you're left with is 3 over 2x plus 1 squared. And you can leave that as 2x plus 1 squared. You do not have to actually multiply this out. If you did, it wouldn't be wrong, but this is not wrong either. And the book is going to have the answer like this. Questions on that? Now let me just, if I could for a second, let me just try and help you appreciate how great this rule is, all right? And the only way I can get you to appreciate it is to go back and remind you that when we were trying to find the derivative at a, this was the limit as h goes to 0 of f of a plus h minus f of a over h. Remember that formula? That's how we did derivatives before I gave you the shortcut rules. That's the way we did them. Let's just look at what a disaster this would be if we did not have that rule. We would have to do limit as h goes to 0. We'd have to do f of a plus h. So we'd have to replace every x with a plus h. It'd be 3 times a plus h over 2 times a plus h plus 1. That's f of a plus h. Minus f of a, which would be 3a over 2a plus 1. And then all of that over h. And then you have to do some algebra to try and make this turn into 3 over 2a plus 1 squared. That's what it would turn into. Like if you did all the algebra correctly, and at the end let h go to 0, you would get this. And the algebra in this is difficult for my Cal 1 students to do. And this is in a Cal 1 class, we stick with this limit for about 3 weeks. And we keep doing more complicated problems. In this class, we did a couple, right? And then we went right to the shortcuts. So this is why we are circumventing having to do something like this. So even though the formula might be ugly and you don't want to memorize it, it sure is better than having to do that, right? Okay. All right, let's do another one. Let's do I'll make one up here. P of x, something like that for profit. Let's do x cubed minus 2x squared over x squared plus 4. All right, trying to find the derivative of this. So we identify f as being the numerator, g as being the denominator, right? And then we go f prime g minus g prime f all over g squared. If you go talk to a tutor, you might hear something like this. I'm not a big fan of things like this, but if you go get help or you talk to someone who has another teacher or something, they may tell you, oh, my teacher taught me this little thing, Lodi high minus Heidi low. It's like a little saying, Lodi high minus Heidi low. And that's a way you can remember the quotient rule. Now let me try and explain what the heck's going on here. Low means denominator, high means numerator. All right, so you know how we're supposed to do f prime times g? Isn't that the low function, which is the g, times the derivative, d derivative, of the high function, which is the f? Yeah? And then minus, we're supposed to do the high one, which is the f, times the d derivative of the low one, which is the g. I'm just showing you that because if you ever hear someone say that, that's what they're talking about. I in no way encourage you to try and remember that, all right? But some people think things like that are cute and they remember them better that way. So if that helps you, great. If not, just memorize it. Okay, here we go. F prime g minus g prime f over g squared. So let me just throw my division in here now. Let me just throw it right there. Okay, f prime comes first. So let's just make sure we're all on the same page. Let's do some random people today. Where's Alea? Alea? Hi. I have not called on you. Right? You feeling okay today?
Yes.
All right. How do you feel about the derivative of f, this first piece? 3x squared. Good job. Minus 4x. Okay, that's the derivative of the top, right? Then I'm supposed to put times. Go ahead, Alea. Am I saying that right? Alea? Alea? Oh, wow, I'm way off. Okay, Alila. Yeah, that's the way it's spelled. Alila. G comes next, right? So what am I going to put here?
X squared.
Okay, x squared plus 4. Now, I just wanted to ask you how I should be using my parentheses, or do I need parentheses here? Like, you're supposed to multiply this times this, right? So do you think I should use some parentheses if I want to do that? Yeah. In fact, I'm going to want this entire expression. That's f prime, right? The entire thing in parentheses times, this is g, there's two terms. I want the entire thing in parentheses here. And that means that when we go to clean this up, we actually have to FOIL this out. We have to multiply that out. It's going to be ugly, but, you know, that's life. Sometimes it ain't pretty. All right, so I'm going to need a longer division bar, it looks like. Okay, minus. All right, who's up? Let's see. Kobe, I don't think I've called on you. No? You ready? You going to finish up the formula for me here?
Yeah, it would be minus
Okay. 2x, that's the derivative of the bottom. And then?
multiplied
Mm-hmm.
times the
X to the third
minus 2x.
minus 2x squared. Anything else you want me to do here? That's all right. Parentheses, yes. You have to have parentheses around this because there were two terms and that 2x must pass through. We all good? Kobe, what am I going to put on the bottom? What am I going to put down here?
X squared plus 4.
X squared plus 4.
Parentheses.
The whole thing, parentheses squared. Now, be careful again. I went over this last class. This right here does not turn into x to the 4th plus 16, okay? I went through this last class. You cannot just square each one and be done with the parentheses. You would have to expand that out if you wanted to, but I told you just leave it alone, right? Just leave it as is. So don't do that. All right, so this is all good, but we're not done cleaning this up. There's still simplification to do here. So on the first top left corner here, I've got to go here to here, here to here, here to here, here to here. And then on this one, fortunately for us, there's only one term here. It just has to pass through like this. So I'm going to give you a minute or two, see if you can't multiply that all out. Once you multiply it all out, collect any like terms together, and then see if you can get a final result. And while you're doing that, I'm going to work it out myself up here. Let's see. Does anybody agree with that answer? No? You one agreement? You disagree? You disagree? Did I mess something up? 12x to the 12x squared? Did I miss an x? Oh, wait, what did I do? So 3x to the fourth minus 2x to the fourth, that's x to the fourth, minus 4x plus 4x cubed. Yeah, that should just be 12x squared. I don't know why I put 10. Okay, so this should be a 12, not a 10. Okay, now, who agrees? Everyone agree? We're good? Okay. What do y'all think? Just gotta take your time, right? Use your parentheses properly, and everything should work out. Okay, I'm gonna give you one to work on just sitting there, all right? Actually, let me give you two to work, all right? I'll give you one that has product rule and one that has quotient rule. So you try these. How about this? First one, you're not going to turn these in, all right? I'm not collecting these, but I'm going to come around and make sure everyone's kind of getting the same thing. Okay, now I'm going to tell you on that one, I want you to use the product rule. Even though I know you can multiply that out and avoid the product rule, I want you to practice using the product rule here. And on this one, I want you to use the quotient rule. Okay? I want you to use the quotient rule. So on this one, I didn't put the instructions. Find r prime of x. And then on this one, find p prime of x. And how about I give you about 6, 7 minutes. Let's see how much you can get done in 6 or 7 minutes. 5x squared plus 4 over x squared. Did I write that correctly? Okay, how many of you agree with this one? You changed your mind now? Do you see what happened? Okay, so big show of hands here, because again, I'm not going to work this out. I don't know if this is right. How many of you agree with this answer? Does anybody strongly disagree with this answer? That we need to visit this? So we're okay? All right, maybe I'll say what the right answer is. It won't be hard. I'll work it out real quick. 10x plus 3 squared x minus 5x squared plus 3x minus 4 over x squared. So 5x squared, did I not? Oh, minus and plus. So 3, yeah, this is right. Okay. Okay. What were one of the tricky things on this one? What was tricky about this problem? The derivative of the bottom, that g prime, was just 1, right? And you had to distribute the minus through. That right there could get you in trouble. When you wrote down f, if you didn't put parentheses, you didn't get that minus to go all the way through. Okay, so Sydney, good job. And let's see here. Armando. Where's Armando? You got picked for the second one, but you get the first one now. 16x cubed, 3x squared, plus 16x plus 2. Okay, agree? Okay, all right, good. All right. Now, let me see. I have some time here. Make sure this comes out. I don't want us to lose sight of what we're doing here. So I thought I'd show you something real quick. Do you know how to turn on the projector over there? That black panel, top left, press on. Yeah. What do those answers represent geometrically? Do you remember what those answers represent? I'm going to do this one, this p of x, this second one. What was it again? It was 5. Was it 5x squared plus 4 over x squared, right? Okay. So why is this not connecting to Google? All right, so what I'm going to do here is I'm going to graph 5x squared plus 3x minus 4 over x. Did I type that in right? Yes. Okay, so that's it. It's a weird looking graph, okay? You see that graph there? Not really, huh? We kill the lights, the left switch, the far left switch. Can y'all see that graph okay? Kind of? Yeah? So what this answer represents to us right here is the slope of the tangent line to this curve. So the graph you see up there is the graph of this function, which could be like a profit function or something like that. And what this represents is the slope of the tangent line at any point. So if we plug in 1, okay? We plug in 1 to this, what would happen? We get 5 plus 4, right? Because 1 squared is 1, so we get 5 plus 4 is 9 over 1 squared is 1, so we would get 9, wouldn't we? So that means if we go to this graph, and we go to 1 on the graph. So here's where we plug in. If we plug in 1, here's where we are on the graph, right there at that point. The slope of the tangent line there is 9. So that, back related to last class, that has to do with what we could call like your marginal profit. It's showing how much your profit is increasing by at that point. Understand? Okay. All right, can you turn the light on and the projector off? Thank you. All right, so you should be able to handle the homework for that section, and I do have the video solutions for that up. I'm going to start the chain rule here, and I do not have the video solutions for chain rule up yet. I'll probably get those up maybe today, but if not, I'll get them up tomorrow, okay? All right, so chain rule. This chain rule is 11.4. I'm recording still, okay. This rule is easily the most powerful rule when it comes to differentiation. The most powerful and the most important. Well, you could argue that. But it is also the one that causes students the most grief, all right? So I'm gonna try and explain to you how this rule works. We can almost look at the chain rule as what we call a general power rule. So let me explain what I mean by that. All right, we know already the normal power rule says if we have x to the n, that when we take the derivative, it's nx to the n minus 1, right? We already know that. That's our power rule that we learned when we first were learning these rules. That works if we have x here, right? X squared, x to the 5th, whatever the power is. Now what we're going to do is look at it this way instead. What if you have a function raised to a power and you want to take the derivative? Not x to a power, but a function to a power. How do you take its derivative? Well, the general power rule says this. You will bring the n out front, okay? You will take f, and you will raise it to the n minus 1. So far, doesn't this look exactly like this rule? Yes? But there's one additional thing that you have to do. And that is you have to multiply this by the derivative of f. Ooh, what just happened there? Okay, let me try and show you on this example, or in this power rule that we have. Let's take a specific example. What if we had x to the 7th and ask you to take the derivative? You would say the answer is 7x to the 6th, right? Everyone understands that? Okay, but instead of looking at x as just x, let's look at it as a function, okay? So let's imagine that was some little function. It is x, right? But let's imagine it's some little function. According to the general chain rule, the power rule here, I'm still going to bring the 7 out front, right? Still going to have 7 times, now the function to the power minus 1. So what was my function? X to what power? 7 minus 1, so 6, right? But now I'm supposed to multiply by what? The derivative of f. But what's the derivative of x? 1. So there's actually a 1 sitting out here. Now I never showed you that before, but do you see that doesn't change the answer? It's the same result. Do y'all see that, where that 1 is coming from? You're now taking derivative of what's down there. This is going to help us work with things that are more than just x to the 7th. So let me give you a specific example of this now. I guess the big thing is this part right here is new, right? That part right there is new. So as an example here, what if we had a function, okay? Let me do it this way. What if we had some cost function, c of x equals, let's go x cubed plus 3 raised to the 7th power. So what I'm trying to get you to see is that this looks a lot like this. The exception is that instead of having x just by itself as a base, you actually have an entire expression here, x cubed plus 3, right? Do y'all see how that part right there, this right here, is the f, kind of like this right here was the f. Understand? Okay, so according to the generalized power rule, the chain rule, the derivative of this should be first the power rule, the 7 coming out, and then what? The function. I'm not going to change it. Just rewrite in parentheses x cubed plus 3, and then raise that to what power? 6. So far, is that okay? Now we have the one additional major piece, which is this one. I need to multiply that times the derivative of the f, the derivative of that. And what is the derivative of this? 3x squared. Here's some, does that make sense? What can I do anything with this? Like this 3x squared, can I slide that out front with the 7? Yeah, it's all multiplication. I should be able to do that. So I should be able to get 21x squared out front, and then x cubed plus 3 to the 6th. And that should be my final result. So it's kind of like, again, we were doing this already. But because we were doing x here, that last piece of that chain rule was always a 1, so we never even really thought about it. But now, our base is not just x, so that piece on the outside is not going to be just 1, it's going to be the derivative. Let me show you some common mistakes that I see with this. Let's take the same problem. This is something I see students do a lot. So what did that student do? Yeah, they brought the 7 out, right? And then they took the derivative of this and raised it to the 6th. That's not what the rule says, right? The rule says bring the 7 out front, don't touch this, raise it to the 6th, then multiply times the derivative, right? So this is incorrect. Let's do another one. This one's tricky. Could you use the quotient rule on that? You could use the quotient rule on that, right? Because you have a quotient, don't you? Let's actually do this with the quotient rule, and then I'm going to do it with the chain rule after that. I'm going to show you that you could actually do both on this one, either one. So first of all, if I use quotient rule, the derivative will be the derivative of the top one times the bottom minus derivative of the bottom one times the top one over the bottom one squared, right? That's the formula. So what is the derivative of the top function? 0. Derivative of 1 is 0. So I'm going to have 0 times the bottom function. Is that even going to matter? It's all going to go away, isn't it? 0 times that's going to kill it off. But that's the formula. That's f prime g. Then minus, what's g prime? 5 times the top, not the derivative of the top, just the top. So just 1. So remember the formula. We've got f prime g minus g prime f. Then all of this over g squared, which is 5x minus 4, that quantity squared, right? That's what we get. And then we said this would all go away, right? That's all 0. And then this just becomes negative 5. Yeah? Okay. So we just get negative 5 on top of 5x minus 4 squared. That's the answer. Questions on that? That's using our quotient rule. Now, I claim that you could do the same problem with the chain rule. But here's how you have to do it. You have to rewrite this function when it was given to you like that. Is that the same function? What does it mean to raise something to a negative power? Well, that means you really drop it down, don't you? So isn't that identically the same as this function? They're the same thing, right? Now, if I'm asking you to take the derivative here, you can use the generalized power rule, the chain rule. So what would I do? Bring the -1 out front, right? -1 out front. Then what? What to the -2? The function, which is what? 5x minus 4. That quantity right there to the what? -2. Where'd you get -2 from? You subtracted 1 from -1. So -1 minus 1 is -2. Am I done? No. Times the derivative of what was here, which is 5. Is this the same answer as this? Are these two the same? They don't look the same, but what does a negative power mean? You can drop it down, right? And what would still be up on top? -1 times 5. So wouldn't you have -5 on top? And on the bottom, when this drops down, you have 5x minus 4 squared. Now, are they the same? They are. Same answer. So you could actually use that if you wanted to, either way. Let me give you another chain rule problem. I want the derivative of this. All right. Is this 5 right here being raised to the 5th power? No. Is this 5 attached to a constant? Is this constant attached to a function? Yes, right? It's like when we have like 5x, right? That 5 is just sitting out in front of the function, and you just bring 5 along for the ride, derivative of x is 1. Okay, so that 5 out front, when I take the derivative, it's just going to come for the ride, isn't it? Because it's attached to a function. This piece right here, I can use the generalized power rule for. I have something raised to the 5th power, right? So let's see. I want to see how y'all are doing with this. I have not called on Jonathan. Where's Jonathan? Jonathan H? John H? No?